Thanks for coming. This is practical exploitation of Drupal vulnerabilities. I'm Drew Webber. I'm McDruid on Drupal.org and have been for a scarily long amount of time, although I'm sure there are people in the room even longer. I am a member of the Drupal Security Team. I've been maintainer of Drupal 7, one of the maintainers of Drupal 7 for the last few years, and I work for Acquia, where I work in the security team there. So what I want to talk about today, we've probably, several of us, if you've built enough websites, you might have been unfortunate enough to see something like this before, where someone says, you know, we type in these script tags into a search form or something like that, and this, you know, an alert pops up. So real attackers aren't going to do that on your website. So if somebody actually wants to do bad stuff to your website, they're not just going to pop something up like that. So I want to have a look today just at some of the things that a real attacker, a real bad actor might do were they to try and attack or to find a vulnerability and exploit it on your Drupal website. So generally in InfoSec, we seem to use a lot of sort of militaristic terminology. Instead of red team and blue team talking about militaristic stuff, let's pretend that I know anything about football, which is not really true, but you know, the red team here attacks, the blue team defends. Why would we, as you know, builders of websites and developers, be all that interested in what the attackers do? Well, I think the analogy is that it makes you a much better defender if you actually understand what the attackers are trying to do. So that's the idea. So why would somebody be trying to attack a website in the first place? There's a few different possible reasons. This is not going to be an exhaustive list, but I think the top one definitely has to be financial motives. There might be non-financial motives. We could call them hacktivism, and some people seem to just do stuff like this for a laugh just because they can, without any real clear motive behind it. But it's useful to try and remember you know, the motives behind attacks when we look at them and when we analyze them. And what might the attackers do? So theft, obviously, if we're talking about financial motives, theft is a very big one. Ransomware, you know, is constantly in the news at the moment. Crypto mining, which I can't really believe that in, you know, 2024 it's still apparently worthwhile to try and do crypto mining on somebody else's CPU without all the sort of specialized hardware that I don't properly understand. But I guess the idea is, you know, if somebody else is paying the electricity bill or the EC2 bill and you can run your crypto miner on it, then it's kind of free if you do get lucky and anything happens. Botnet recruitment, if again, probably financial motives. Somebody might be just trying to hack as many machines as they can all over the place to try and assemble a big botnet that they'll then do other bad things with, whether that's, you know, DDoSing people or sending spam emails or whatever. So they might be trying to recruit your machines into their botnet. They might be trying to achieve lateral movement. So they might not actually be interested at all in the web server that's running your Drupal site, but that web server might be connected to your corporate network, probably more so the case before cloud came along, but not always. So they might want to just use your Drupal site as a foothold to get into the network, and then they'll sort of pivot from there to go and do the things that they really want to. And things like defacement still seem to be a thing. So I'm going to make a bit of an assumption as we look at the vulnerabilities and the exploit as we go along. that assumption is that attackers want a shell. This isn't really always true, but it's kind of a useful abstraction just to think that what the attacker's trying to do is get a shell on your web server. So it means they're actually, they're able to just use your web server as if it was their computer. They can do whatever they want on it. When we look at things like, the financial motivation, there may be completely different threat models. In your case, if you are running a cryptocurrency exchange in Drupal, first of all, good luck. But secondly, your threat model hopefully will involve understanding that people are trying to steal keys and etc. But let's just assume that all attackers want to do here is get a shell on the machine that's running your Drupal site. So we're going to look a couple of times at what's a reverse shell. A reverse shell, if you haven't come across it before, I know there is a spelling mistake in this. I've kind of just stolen the slide off Google, and I noticed the spelling mistake afterwards. A reverse shell is a bit different to what we probably have all done lots of times, where you SSH into a machine and you establish the connection and you talk to the shell on the machine. A reverse shell, as the name suggests, works the other way around, where you're able to execute something on the target machine that makes it actually reach back to you and then say, what do you want me to do? So the shell is actually coming from the machine back to you instead of the other way around. You can, if you have a look online, there are hundreds of tools to help you sort of build little payload code that you can run. If you manage to exploit a vulnerability on a website, you can run a little snippet of code. That one's obviously a bit difficult to read, but you can choose from a whole menu of different languages and tools that you might be able to use in order to make that reverse shell happen and the connection to come back to the attacker's machine. And this is what a reverse shell might look like. If you are sitting, waiting patiently for a connection to come back to your machine, and then you've managed to hack someone's Windows XP. It's probably a cash machine or something in a hospital. And the reverse shell's there, and now you can just type in as if you were sitting at the console on that machine. That's what a reverse shell looks like. Netcat's listening on port 8080. We often call these Netcat shells because the simplest way of doing it is you sit and you're listening for the TCP connection using something like Netcat. So let's look at a few actual examples of things that might be exploited. This one isn't the most technically dazzling, but it's probably the one that I actually see in the wild, if you like, happening most often. So weak authentication. Bad passwords are, again, kind of unbelievable that we're still struggling with this, but it's the real basics, like, wash your hands after going to the toilet type level of hygiene, but we still seem, as an industry, to be able to get this stuff wrong quite frequently. There's a couple of Drupal.org issues here kind of arguing in both directions. I think one of them was saying, let's stop having it so that Drush leaves a really weak default admin credentials on sites when you do an install. And then another one is a different project saying, oh, it's really hard to figure out how to log into a site when you've just set it up with this. Let's just set it up as admin. And it's surprising how often people end up leaving those sorts of crazy defaults and deploying them to production, and you end up getting compromised later on. This is a kind of shameless plug. It's a tool that I wrote called Drop the Ripper, which is very much inspired by John the Ripper, the password cracking tool. This is a Drush command that runs, I think, all the way from Drupal 7 up to D11, all the versions of Drush, if you can come up with the right incantations to make it run. And it will check for really, really weak passwords in the system. You're able to also have it particularly check for weak credentials for users that have restricted permissions, so the ones that you'd be particularly concerned about. Credential theft obviously is nothing new, but with websites like Have I Been Pwned, you don't necessarily have to have admin. You could have a really strong password, but if it's been compromised elsewhere and reused, attackers are going to be trying to use those compromised credentials to log into Drupal accounts on your site. That was to represent phishing. Obviously, if someone successfully phished somebody and they've got hold of their credentials, they'll be able to do it. This is an example of using an automated tool to do a brute force attack on a Drupal website, where effectively it's just submitting the user login form repeatedly, trying default credentials or a word list of credentials that you've harvested elsewhere. So this is sometimes called credential stuffing. Just to mention that Drupal core has a sort of secret weapon against this, which isn't obviously completely bulletproof, but Drupal core has flood control, which means that if you actually try to do a brute force attack with the list of the 1 million most terrible passwords, it's going to take you a really, really long time to submit all of those to a Drupal site because of flood control. Because after I think it's on your 5th attempt to log in, Drupal's going to start blocking you and making you wait ages before you try another submission. So this is one of the things that Drupal core by itself does really well. Let's say the attacker manages to guess the credentials and they log in. If you're unlucky, they manage to log into your site as a user that's got high privileges. What are they going to do next? So remember, our assumption was that they want to get a shell. So this has just, I think, been removed from Drupal core, but until fairly recently, depending on how your site was configured, how the hosting was set up, there's a UI in there to be able to go and install your own module. You can choose one from D.O, or you could upload your own module, as a zip file or an archive. So you can put whatever code you want, upload it, and away you go. I think I've got a note here to say this was removed from the UI in 10.4. So only very recently has this become not a thing. There's also everyone's favorite, the PHP module. This is still there in Drupal 7. It's, I think, installable in newer versions of Drupal, but there's a not very subtle, huge warning on the project page sort of saying, please don't do this, reconsider your life choices. But there's still 7,500 sites reported as having that module installed. So if the attacker gets this far, with something like this, it's probably not going to be that hard for them to get that shell and start running their code on your website. I don't want to go through each of these in lots of detail. I've got a bit too much to cover as we go along. If I was going to mention one of them as a mitigation for weak credentials, multi-factor. I'm sure I'm preaching to the choir when I say that multi-factor is something that you should be encouraging everybody to use and using yourself, and it makes brute force and that sort of thing much less feasible for the most part. So this one is a bit different. Server-side request forgery. Portswigger, who are the maintainers of the Burp Suite tool, have some fantastic content for free. If you want to learn about any of this stuff, they've got a good explanation of what is server-side request forgery. So the idea here is that the attacker is able to send things to the website, and the website hosted on the web server has access to all this stuff, which is, on that side of the screen. It's behind the firewall. There's infrastructure there that you wouldn't allow the attacker to interact with directly. And the idea of server-side request forgery is that the attacker is going to try and use your website in order to interact with things that they're not supposed to be allowed to touch inside the internal network. So if we look at some examples of what, potentially vulnerable functionality that you might see very commonly on a Drupal site, I'm sure we've all seen lots and lots of these where it's, put in the YouTube URL and we'll go and grab the video for you. There might be loads of other examples. It might say, you know, put the URL for your avatar or your public key or whatever it is. So in these cases, you have to be really careful that what you're not doing is essentially the equivalent of just saying to the stranger who's come in off the street to use your website, here's my browser logged in, you know, just come and do whatever you like with it. I'm sure I can trust you to just go to download your YouTube video or whatever. But I mean, that is what sometimes happens, that you without the proper validation, user input validation here, an attacker might be able to just put whatever URL they want into that. And depending on how you've implemented this, you know, it might not need, the attacker might not actually need for your system to do very much with the URL in order for them to achieve their objectives. So, I mean, this is, if you were able to abuse one of those bits of functionality, let's say you're giving the URL for your public key, if you're able to put this URL in for the AWS metadata service, if you're unlucky on your website, what it might be doing is going off and grabbing a load of secret credentials for your AWS account and saving them into a place that the attacker can then go and look at. Might seem a bit far-fetched, but this is kind of how Capital One got breached, I think in 2019. At the time, you know, one of these absolutely enormous breaches that cost millions and millions of dollars. It wasn't a Drupal compromise, but it was someone was able to actually, you know, do a server-side request forgery, get the EC2 metadata out that way, and that gave them access to S3, so they could go in and go crazy with a load of data that they weren't supposed to have access to. So how do you avoid server-side request forgery? I mean, saying validate user input seems like, you know, it should just be table stakes for any kind of security talk, but validating the user input is the basic answer to that. So you might want to allow list, you know, the protocol, the URL, just make sure that if you're expecting it to be a URL for YouTube, that it actually looks like a HTTPS URL for YouTube and not something completely different. You might try and block IP addresses from that previous example, but there's nothing to stop an attacker having public DNS records that resolve to whatever IP address they want. So just blocking IP addresses isn't much of a defense. You might take the URL that they've given you and do a DNS lookup on it just to make sure that, okay, does this look like something that I want to be connecting to? But depending on what the attacker is trying to achieve, your web server doing a DNS lookup to some arbitrary domain that they've just supplied might actually be all that they want to do. They might be trying to find out where is your site actually hosted if it's behind a WAF or something like that. So you need to be careful about even doing something like a DNS lookup to validate what input you've been given. Another sort of tip for mitigation is, you know, a sort of zero trust architecture. Just a simple illustration here of sort of if you, just because you've got a service that's only listening on localhost or only accepts connections from within the VPC or whatever it is, don't just take it that if anything is able to successfully connect to you, it must be fine, it must be legit, it must be authorized, because it's coming from inside the house. There's, you know, the AWS metadata service has now got better protection there to make sure that it's not quite so simple to just send one HTTP request and get all the metadata back. You have to do multiple steps and supply custom headers and that sort of thing. So that's kind of an example of just not trusting just because we've received this request from somewhere that's able to actually connect to us over the network, that it must be fine. SQL injection. Everyone, I imagine, will be very familiar with this. It's very old now, but I have to mention, if we're talking about SQL injection, you know, the famous Drupal 1 from 10 years ago, we're looking at our assumption about what does an attacker actually want to do. If we assume that they want to get a shell on your server some of the common exploits for Drupal 1 were using that SQL injection to add an administrative user to your website. So there's an example of, I think it's a Python script that you just say, right, I want to be able to log in with these credentials, point it at the website, and there you go, it's added an administrator user to the site for you. Just very quickly, the Drupal, the database API in Drupal keeps us safe for the most part. And if you have a really silly, sort of naive SQL injection vulnerability, I don't know how easily you can see this, but it's more or less just a case of, you know, passing user input straight into a SQL query without any validation or using the API properly. It's not possible to do the sort of old school typical chaining queries. You can't do the, you know, little Bobby tables, just put your own query on the end of it. The way that Drupal uses PDO won't allow that to happen. So that kind of keeps us safe a lot of the time, but it doesn't mean that you can't still exploit a SQLi vulnerability on a site. So this is a blind SQL injection where the idea is it's almost like you get the opportunity just to ask the site a binary question, a yes or no question. So this is an example of a Python script which will iterate through the entire password hash in the database, and it will just keep on asking the site, is the next character greater than X, you know, in the ASCII table. So effectively, it takes a little while to do it, because each time you ask that question, if the answer is affirmative, then the database sleeps for a couple of seconds and you have to wait until you get the response back. So this is sped up. It takes a lot longer than this, but that's just using that particular SQL injection vulnerability. You're able to go through, extract the entire password hash out of the database, and once you've got that, it's down to, you know, how strong is that hash in the face of modern computation with trying to crack password hashes. So in this case, it's not very strong. The password is Barcelona, but you obviously don't want to let people be able to extract your password hashes out of your database. If this was to happen on your website, if in that silly example that I gave, the malicious payload is in the GET request, so you would see hundreds, if not thousands, of these URLs in your logs. So it's not exactly a subtle attack, is what I'm saying there. It may be that the payloads are in post requests, in which case they might not be quite so obvious in your logs. But the unfortunate thing to say is that it's also very common to see stuff like this in your logs all the time, just because the internet's not a very nice place. And it doesn't necessarily mean that you have an exploitable SQL vulnerability on your website. But if you did, that might be what it would look like. So how do you mitigate SQLi? Well, as I mentioned, the database API in Drupal generally keeps you safe. Use it carefully, though. There's a core issue there where not every single one of the API functions that you might assume is going to do all of the validation and sanitization for you. Don't necessarily make those assumptions. You know, you still have to be very careful about passing unsanitized user input into in SQL queries. Remote code execution is, you know, kind of a big umbrella term. In general, with the other ones that I've looked at here, I'm looking at things which I think might actually be quite commonly exploited, or at least people be trying to exploit them on your site. The form of remote code execution that I want to look at next, I don't think is probably one that does come up very commonly or very often, but it's just one that I think is really interesting and really cool. So it is, oh, sorry, I've skipped ahead of myself there. If we're talking about remote code execution, Drupal 2, a few years later than the first one, was a remote code execution vulnerability. I was working in the SQL Security Team when that happened, and about a month after the SA, and after it became publicly known, and when proof of concepts were out there, we started to see what looked like quite a big attack. And what was interesting about this, sites that were hosted on Acquia weren't vulnerable to the to the vulnerability, regardless of whether they'd patched or not. But we could still actually, this was a self-propagating attack. So the attacker was actually trying to exploit the vulnerability, and once they successfully managed to do so, they were kind of recruiting each machine that they'd managed to compromise. It was then trying to send out lots more attacks all over the whole internet to try and recruit more, vulnerable Drupal sites into this sort of like a botnet, but it was actually trying to run crypto mining on web servers. So I don't think they really made a huge amount of money, but it's hard to guess. We were able at Acquia to analyze the logs, and like I say, without any of the sites that we hosted being vulnerable to it, we could see the attacks coming from what we can only assume are compromised websites all around the world. And there's some numbers in a blog write-up there, but it was coming from all over the globe, thousands of compromised sites. There's a blog post about that if you're interested in seeing the detail. So I jumped ahead of myself a little bit and said, for remote code execution, I want to talk about insecure deserialization. So I'll try not to go too deep into the weeds about this, but I think this is a really cool exploit and a really cool vulnerability. And the idea is that PHP and other languages allow you to serialize objects, which I kind of think of, I might be showing my age a little bit, but it makes me think of Batman in the really old Joker, the Joker in the really old Batman TV show, where he used to be able to dehydrate people into a little pile of coloured dust on the ground, and then he could get them inside the museum and spray water on them, and they would pop up and rehydrate. So this is a bit like what you can do with an object in PHP. You can serialize it down into its sort of into a string representation, and then later on you can bring it back into existence by unserializing it. The problem from a security point of view comes when PHP has these magic methods, and amongst them, probably the most interesting from this point of view is the destruct method, but some of the others can also be used for this exploit. So if your class does something in its destruct method, typically with one of the properties, if you allow that serialized object to be tampered with by an attacker, they're able to do some really clever things where when that object is brought back into existence briefly and then is destroyed again at the end of that request, the magic methods like destruct and a couple of the others, wake up even, will be run. And if you're able to inject your malicious payload into that object, you can come up with some pretty creative ways of actually making this do bad things. So just for giggles, this is me in 2015 trying to submit a core patch which would have introduced an insecure deserialization vulnerability into core. Thankfully, Gabor was there to say that doesn't seem like a very good idea to me. So I'd like to think I wouldn't try and do that again, but just an illustration to say that, we all make mistakes and we're all learning all the time as we go along. So I talked about, how you can come up with some pretty creative ways. A very simple insecure deserialization exploit is quite a straightforward one, but you can get some really creative gadget chains, they're called. There was a toolkit built, I think, first of all for Java. It's also available for .NET, called Why So Serial. And PHP GGC, generic gadget chains, is like a PHP version of that. And this is a collection of gadget chains that people have come up with where they're able to sort of string together all sorts of classes that you would never normally have thought, we'll shove one of those into an object of a different type. And they're able to put them together into a way such that at the end of the deserialization, the attacker is able to do remote code execution. At one point, there were 2 gadget chains for Drupal 7. Pleased to say that we fixed both of those in core, so they won't work anymore on Drupal 7. There is one also for Drupal 9. We tried but didn't manage to get that one fixed, but it was using a component that has since been removed from Drupal core. So if you were running a really old version of Drupal 9, this would still be a thing. But it's important to point out that you need to actually be doing unwise things with, you unserializing user input for it to be a problem in the first place. But I don't know how easily you can see there, but you can, the best thing to do is if you're interested in this stuff, go and look at that core issue where we looked at whether we could fix this or how we could stop it being a problem in Drupal 9, because it was along the way I learned quite a lot more about how this stuff works. There's some interesting things like the fact that the constructor never runs in these classes. So even if your constructor says, don't let some crazy other object be passed to me in one of my properties, when your object is deserialized, the constructor doesn't have anything to do with it. So writing some protection in there is not going to help you. So it's quite an interesting deep dive, which I haven't got time to go all the way into. The good news is that it's pretty unusual to have a proper deserialization vulnerability. There have been a couple in Drupal contrib over the years. This is one which I found a few years ago in a module called table field, which slightly naively it is also a form of IDOR, insecure direct object reference, where you could construct a URL where the module would actually just load a field from the database and run it through unserialized, which meant that if you as an attacker had the ability to put your payload into a particular field in the database, you could use this. So it was actually possible. I think probably the most common way that it might have ended up being exploited was if a user was able to post a comment. They could then construct a URL which table field would dutifully go off and load that comment out of the database and run it through unserialized. So this is actually, I've got a blog post there again if you're interested in looking at all the details, but it's possible to use this vulnerability to get a reverse shell out of a Drupal 7 website. If your site is still vulnerable to that, you're about 5 years behind patching, so I don't feel too guilty about publicly talking about it. What can you do in order to avoid this? Well, the simplest thing, obviously, is just don't ever run anything that a user has been able to tamper with through unserialize. More modern versions of PHP have extra arguments to unserialize, where you can say, don't allow this to create classes when you're doing it. Most of the time, if you need this, well, I won't say most, but a lot of the time, if you're trying to use this, just ask yourself whether you can use JSON decode and encode instead, because in many cases you probably can, and that's one of the fixes that we've sometimes done for it. Static code analysis is quite good at finding these problems in a site if you manage to run static code analysis on your site. It's an easy one to avoid because you have to do something very specific to make yourself vulnerable to it. So I just want to talk quickly now about, we've run through a few examples of different ways that your site might get hacked. How could you detect some of these things happening? Well, in some cases, the attacker, when they've managed to compromise your site, they're running a binary on your site. It might be one of those reverse shell payloads that we looked at, where they might be using, Ruby or Perl or goodness knows what to achieve that reverse shell. If you're looking, if you're able to look or inspect the process tree to see what's going on, if you can see, a Python script being spawned by your PHP processes, which is then in turn spawning a bash process, maybe something bad is going on. It would be a fairly good thing to go and look at. There can be reasons why that sort of thing happens. Sometimes a web process might be invoking a binary on your web server to run, clam AV scanner or something like that. But if your PHP processes are spawning other binaries, then you better check that it's legitimate what's going on. This is an example of CrowdStrike finding some malicious binaries, which again, the parent processes are Apache. So if you're able to run something, like an EDR like CrowdStrike, it might well detect this sort of thing going on and warn you about it. Insert snide remark about CrowdStrike taking everything down in the whole world as well. But so obviously attackers know that it's not exactly subtle to spawn weird processes. So there's a whole library of tools out there called lolbins, which is living off the land binaries. And this is kind of where on Windows and on Linux, you might find a host of tools which will already be on the web server environment, most likely, but that you're able to abuse in some way or another and make them do something. So Netcat is a good example where you don't have to inject some strange binary which is difficult to get onto the server in the first place and will set off all sorts of alarms for what's this weird thing doing, if you can actually use a tool that's there all the time, so lolbins. And web shells also, if you actually just have a PHP script on the site that's just accepting user input, that's not going to show up as a weird alien binary, because what your web server is doing is just running PHP scripts all the time. So you might be able to detect things going on in the network. Reverse shells are far from subtle. So in this case, you can see those TCP connections going out to from my web server out to the attacker's machine. So if you've got detection going on in your network, first of all, you might not want to allow egress to just any port for TCP connections going out. And in the very basic Netcat reverse shells that we looked at there, I wasn't using any encryption or anything like that. So if you do actually find any of these happening, the commands, all of the traffic is actually going backwards and forwards in plain text. So again, this is far from subtle, and if you were able to actually pay attention to what's going on your network, you'd be able to detect and see all of this happening. However, attackers aren't stupid, and they might, again, try and sort of hide in plain sight. This is an example of a reverse shell tool which is implemented entirely using HTTPS as the transport. So all you would see is encrypted HTTPS packets going backwards and forwards, which, again, it's kind of hiding in plain sight on a web server, because that's a pretty normal thing to see a web server doing, and you might be able to get your reverse shell going on there. DNS tunneling is another, if we're talking about blocking the egress from your web server, it's very typical to allow 443 out, which would be, that previous reverse shell. You'd also probably going to allow 53 out, maybe, depending on your use case. But attackers can use DNS to do their malicious traffic over your network and maybe get through your firewall rules and evade detection, because you might not be looking out for this sort of stuff. Right. Good. I think I've tried to race through quite a lot of content there, and it's late on in the day, late on in the conference. Hopefully I haven't sent too many of you to sleep. Are there any questions before we move on?
Is there an easy way to find out, firstly, thank you very much for your talk, it was very interesting. Is there an easy way to find out what site is using which module? I mean, there's statistics recorded on Drupal.org, but is there some API exposed that would show what site is using what module anywhere that you're aware of?
Not that I'm aware of, other than there's the statistics that are shown in various places on Drupal.org. I don't actually know the answer as to whether you can whether you can interact with the API, which I know you can and tools do, but I don't know whether there are any API endpoints that reply with the usage statistics. I'd have to go and find that out, but it's definitely exposed through the UI on Drupal.org for individual projects, and sometimes you can see it broken down by versions, and you can see who's horribly behind on their patching and that sort of thing. No other questions? Okay. Contributor workshop, please go and take part. I'm not going to embarrass myself by trying to pronounce things in Spanish, but thank you very much. And that's the QR code for the session feedback, if you'd be so kind. Thank you.